all of which has mass and occupies space, is known as matter. On a superficial level, the theory of relativity, the understanding of gravity, and even quantum physics are all well-known topics in more than just the scientific community. In fact, these ideas have become a part of the popular consciousness. But at an elementary level, each theory would not be conceivable without matter. In essence, matter is that which has mass and occupies space. This table, the device you're viewing this on, this sterile, two-dimensional, faceless anorexic with no hands or genitals. This stick man. We're all made of fundamental particles which are simply excitations in the pervasive quantum field. But we know these particles more commonly as quarks and electrons, as well as the slightly rarer particles of matter, such as tauons, muons, neutrinos, etc. Interestingly enough, for every type of particle of matter we've found, there also exists their corresponding antimatter, which are nothing less than an opposite excitation in that analogous quantum field. Matter and antimatter, they are, we can say, inextricably linked with each other. It appears we're reaching a crucial juncture right now. This is the pivotal part, however transient it may seem. You see, the number 7 has exactly the same properties as -7, yet one is positive and the other is negative, and when they encounter, they annihilate. Similarly, antimatter looks and behaves just like their corresponding matter particles, except they have opposite charges. For instance, an electron is electrically negative, whereas an anti-electron or a positron is electrically positive. And when these two encounter, they too annihilate completely. It should be noted that gravity affects matter and antimatter the same way, because gravity is not a charged property, and a matter particle has the same mass as its antimatter particle. Similar to how matter make up protons, atoms, and molecules, antimatter can also make up antiprotons, anti-atoms, and anti-molecules. And in the vernacular, for anything and anti-anything can also exist. These are the truisms that we cannot deny. A final codicil to this matter is, if antimatter and matter are exactly equal but opposite, then why is there so much more matter in the universe than antimatter? Well, we know for a fact that there is more matter in the universe because if there weren't, all would be annihilated. We don't know why it is this way though. But yes, it is a question that will stay with physicists even as they sleep. With that said and done, we know 1. For every particle or matter that exists, there exists antimatter. 2. Gravity affects matter and antimatter the same way. 3. Upon encountering each other, matter and antimatter annihilate. 4. No one knows why, but despite matter and antimatter being equal but opposite, there happens to be more matter in the universe than antimatter. Now, whether matter matters to you or matters to me, I have other matters to attend to. Farewell.